Okay. Can everyone see this presentation mode of my PowerPoint? Everything good?
Yeah,
Good.
looks
Okay,
good.
very good. Alrighty. Hello, everyone. Thank you for being here. So today I'm presenting my first data science Python project using a Kaggle dataset with movie data pulled from the API of the TMDB website, also known as the movie database. Here's a screenshot of their homepage. What is the TMDB, the movie database? It's not the same thing as IMDb. So, IMDb is also an online database for movies and TV shows, but it's more for profit. It's owned by Amazon, and it's more of an industry standard, as opposed to TMDB that works more like a wiki. It's community driven, like a nonprofit, where you as a user can go in and edit and input your own movies a lot easier than an IMDb. Yes. So the data set that I got from Kaggle specifically is for TMDB's 2024 most up-to-date version, pulled from their API, updated daily. It has around 1,200,000 inputs of movies and 24 features. So a lot of people have heard about IMDb, but it's not as much about TMDB. So I thought it would be worth it to do a look into what it has to offer. Okay. So my core research questions are, how do ratings and budget affect ROI, return on investment? And how has movie runtime and genre popularity changed over time? So before we get into all that, here is a list of all of the features in this data set with a matrix showing how many missing values each feature has. So some are pretty good, while others are kind of sparse, like tagline, which is like summary, and production companies. However, this can be a bit misleading because you would think revenue and budget here with the arrows are full of good data, but this doesn't indicate all of the zeros in the column. So in this next series of visualizations, on the left side here, you see top columns ranked by number of zero values. So in actuality, the columns revenue and budget are mostly zeros, 96.2% for revenue and 94.7% for budget. And here in the middle, you see the same visualization as a matrix, now in horizontal bar graph form. And here on the right, you see missing values and zeros combined. So revenue leading, then budget, followed by others. Now, intuitively, you might think this data set is something quite wrong with it because of the amount of missing values. However, upon analyzing it and then the visualizations to come, you'll see that the movies that have a lot of values there, that don't have a lot of missing values, tend to be theatrical, with wide distribution. All that to say, it's still good doing analyses on this data set. It will still give you good value, as we will see moving on. There's one column I wanted to elaborate on because I'll be talking about it in another visualization. Vote count is a feature on the TMDB website that indicates how popular the movie is. So vote count more or less above 100 indicates it was a theatrical release that had wider distribution. Under 100, it was more of a niche, straight to streaming, international film that not as many people were aware of, at least in the TMDB community. Most movies tend to fall between the 1 to 5 range. So the next series of visualizations focus on finances. So here we see a scatter plot with the y-axis being revenue and the x-axis being budget, with the different colors of each circle indicating the movie's rating from poor, average, good, and excellent. Here's a break-even line. So when the movie is above this line, it got its money back and more. And because so few films actually have positive revenue and budget, so this is a subset of the data, 1%. to make sure each title has both positive revenue and budget, and I excluded films that have missing rating categories since it just wouldn't work for this visualization. So a lot of these films were theatrical releases, like Teenage Mutant Ninja Turtles, Across the Spider-Verse, Meg 2, etc. Now, this is a little bit hard to look at because of how dense and concentrated it is down in this section here. So I decided to blow it up to the 100 million point for revenue and budget. So here it's a little bit better. You see more of a distribution of average and good across this section here. However, there's still a middle section that's really hard to identify here. So at this point, I decided to create 4 separate visualizations that each focus on a separate rating category. Here it is. So here we can see exactly how each rating to 100 million is doing for those movies. So poor, you see quite a few of them are below the break-even line, as we would imagine. And average and good are pretty widely distributed across the graph, with good seeming to be a little bit more above the break-even line here. Now, excellent films, much more than good, are above the break-even line. Now, what's most noteworthy is the stark differences between poor and excellent, which I want to touch on here. So here, you see the average budget of poor is actually higher than the average budget of excellent films. And that was interesting because it doesn't really follow intuition. So I attributed this to the fact that when directors are given less budget, they're focused on being more innovative, more scrappy, more inventive with the limited budget they have. And that kind of forces them to make even better quality films, as opposed to poor films, because the data seems to show that they have higher budgets that the production companies are pouring into these movies that just aren't performing well. I also want to draw attention to so for poor films, 125 of these films have profit greater than 0. 124 films have profit less than 0, so kind of even. Now, however, excellent has 849 films with profit greater than 0, which means above the break-even line. And the profit less than 0 is 239. So excellent films by far exceed poor when it comes to ROI. Yes. Okay, moving on. Here's a graph looking at top 20 production companies by budget versus revenue. On the y-axis, you see average revenue per film, and then on the x-axis, you see average budget. And then the size of the circle indicates number of films produced. And the hue, the color of the circle itself, is another indicator of ROI. And here is the break-even line in the middle. Please note this graph is actually in log scale, because if it weren't in log scale, what would happen is all of these production companies here would be here in the bottom left corner, and it would be just hard to separate one from the other. But one thing that would stay consistent across both versions of this graph, you would have these 4 production companies outperforming all of the others. In fact, the distance between Pixar and Illumination from all the rest becomes larger if this weren't in log scale. But focusing on this specific graph, what's most noteworthy is the best performing production companies up here, the Star Wars, the superheroes, the Toy Stories, they don't have as many movies produced as production companies down here, like a Universal or Columbia, which would indicate to someone that it would be much better for a production company to invest more of its resources in movies that can turn a higher ROI than just investing in a lot more mediocre films. It seems to be the case here. Okay, moving on. The next series of visualizations focus on more geographic analyses from the data set. So here we see a continental distribution of movie production, with Europe, North America, and Asian films in this data set being the most present, followed by films from Latin America, Africa, and Oceania. Here's another horizontal bar graph visualization showing the top 20 countries by movie production. United States by far is the leader here, followed by France, Japan, Germany, and the UK. What's noteworthy here is that the top five countries here have about 57.2% of the total share of movies in the dataset. So well over half of the films in the dataset come from either of these five countries, which I thought was noteworthy. Yes. So here's a visualization that focuses on ROI by country. And I put a little explainer here because it might not be completely intuitive. If the country has a ROI of 0, then on average, it broke even. It got all its money back for the amount of money invested into those movies. If it has an ROI of 1, then it doubled its money. It doubled its profit. If it got an ROI of 2, then it tripled its profits. So it's good to like read this graph with the legend on the side. Anyway, leading is the United States, followed by Japan and India, which is noteworthy because these two countries were not nearly as highly ranked in the previous visualization, followed by Australia and the UK and the rest. So here we have top film producing countries, rating in the x-axis and revenue in the y-axis. So here we can see countries like Japan and India doing a lot better when it comes to average rating or like audience reception for their movies compared to other countries that both make more movies, as indicated by the bubble size, and make more revenue, like the UK. So Japan and India are exceeding some of their more powerful peers here. China is also noteworthy for having much higher revenue than the US and UK, despite having less films produced than some of its European and North American counterparts. Yes. Okay. So here is a world map I created that shows a bit more of a granular look at the data set in terms of global movie production by country. So the darker the color, excuse me, the more films that country has produced, as seen in this legend right here. It shows the aggregate sum per decade from the 1920s to the 2020s with this slider in the bottom, which can be played like a video, which I will demonstrate now. Okay, so
I think things gonna change really soon. China is not buying any Hollywood movie anymore, and
yeah.
Chinese investor is not investing in Hollywood. It's gonna be a big difference soon.
Alrighty, I'll follow up with the 2025 TMDB Kaggle data set. Alrighty, so the next two visualizations focus on two specific features for movies, their runtime and their genre. So in this line graph, you see two lines. You see the median runtime for movies across time, as seen in the x-axis, and then you see the 10-year moving average here. So please note that I was only able to do this analysis on approximately half of the data set because of the missing values in runtime. That said, it's still 677,000 movies. Now, there's something misleading about this. It doesn't make sense that after 2000, runtime like hits the floor because I think some of us can agree that sometimes we go to the movies and we think, hold on a second, movies are getting longer. So this is not, this is misleading. So for the next visualization, I decided to isolate films that I know are theatrical from all other films, as you will see here. So on the top line, you're going to see movies I filtered in using a theatrical filter. I only put in movies for this top line where the vote count was greater than 100, where the revenue was greater than 100,000, and the budget was greater than 100,000. And the bottom graph is just all other films that don't fit into these three filters. That said, across both lines, I had to do some filters to make it accurate. I made sure that zero or negative runtime values were removed because those are errors. Have unreasonably long runtimes over 300 minutes because that's more than likely a TV show, an error. And have missing release year values because then that just wouldn't work for the x-axis. And then I filtered out films with fewer than 10 movies to ensure statistical significance, just to make everything more accurate. So here you can see that theatrical films for the last, say, 4 decades have been pretty consistent when it comes to their average runtime. But the same cannot be said for all others. And I attribute this to a couple of things. Um, for one thing, because of the streaming era, there's a higher international market for films that may not necessarily follow the same rules when it comes to our, standard runtime. Um, that said, there's also a lot more digital, straight to streaming content happening that doesn't necessarily have to follow the same rules as theatrical runtime. So that could be a reason. Another thing I thought was TMDB was founded in 2008, right here. So you can imagine that they were a lot more diligent in inputting films into their database after this point. So that might be another reason. And yes. So we solved this mystery. Very good. So this next graph focuses on genre popularity over time. So the way you read this tree map is you identify the genre you're looking at with its color here in the visualization. And then you just kind of see, oh, how's it doing over time via the x-axis, which shows decades. So like from the naked eye, you can see documentaries are doing super well. You can see other genres are doing a little less well. Some are a little more consistent, like drama. Like so, these text boxes I just included to help the viewer know how to like read the changes in these bars. But this doesn't really mean that by the end, drama has increased by 5.6%. This is just an indicator, but by the 1950s, dramas have increased by 5.6%, just so you know how to kind of read this graph. Um, So some important things that I glean from this is that in the last century, the growing genres, the leader was documentaries. Documentaries from 1920s to 2020s increased by 16%, followed by horror in second place and thriller for third place. Now, overall, from 1920s to 2020s, these were the three genres that lost the most. So you have dramas, surprisingly, that lost 11.8%. Then you have romances, excuse me, then you have comedies that lost 13%. And then you have romance that lost 4.6%. I thought this was especially surprising since you would think that wouldn't happen. Like genres like drama, comedy, romance seem to be more evergreen and constant than documentaries, horrors, and thrillers. I think what might be happening is over time, because more movies and more digital content is being made, genres like horror and thriller, and even documentaries, they might have subject matter that's more provocative and therefore will attract more attention than genres that might be more tame and like relaxed, like romance, drama, and comedy. So, in order for production companies to have their products stand out in the marketplace, they might be leaning nowadays more towards, the thrillers, the horrors, things like that, because it's more likely to provoke a reaction and draw people in. Yes. Okay, so at the end of all that, connecting it back to my research questions, I can firmly conclude that rating is a bigger indicator of ROI than budget. Countries with less film production can have higher ratings and ROI on average, like Japan and India, as we've discussed. Theatrical film runtime has plateaued over the last 4 decades, while non-theatrical film runtime has decreased in the last 2 decades. And genres like horror, thriller, and documentary have increased overall from 1920 to 2020, while more classic genres like comedy, drama, and romance have decreased overall. Okay, now talking about future work, I think this project would be worthy of. I would encourage to develop a robust missing value strategy across multiple sources, really because so many features had too many missing values to do certain analyses. So if you could somehow ingest data from other sources like IMDb, for example, you can use this data set to do a lot more. Second, if we can identify what information is available about the movie before its release date, it could be possible to create a predictive model using those features to inform things like, say, ROI. So, like a modeling project. Right. Thirdly, I think it would be worth it to create a dashboard for country view so that you can see things like film production, ratings, and ROI, like for one country. And then because it's a dashboard, you could like make it so you can compare it side by side to another country across any metrics you want. Very interactive. So that's something that this project would be worthy of. And that is it for me talking. Now it's Q&A. Go ahead, guys. Yeah.
Yeah, nice job, Jorge.
Thank
That's
you.
very interesting. Was there any data on this site about like the nationality of the reviewers? Was there like what country they come from when they're posting reviews or
Right. That's a good question. No, not that I. No, it's only really data about the films itself.
okay.
Right. It's not about like so you as a user can go into TMDB and upload a movie you care about that's not already there. So no data about you is now associated with that movie. At least okay, in this data set. At least in this data set, yeah.
Okay. No, yeah, this was pretty interesting.
Thank you.
Good job.
Yeah, this was really interesting for me because I know about IMBD, but this was like a new scope for me. So I learned a lot and the visuals were very descriptive and you explained explicitly. So really good.
Thank you so much. Appreciate that.
Good job, Jorge. How would you compare this one to your last one?
Oh, night and day. Like, oh man. This is like for context, people, the last project, this is on the record. Like I did like three different types of visualizations. Like it was not, I was not proud of it. But here, like I gotta give all thanks to Vinod. Like Vinod taught me what to do. He pushed me, he encouraged me. Like he was like, Jorge, like go crazy, do a lot of visualizations, and then we're gonna like hone in on the ones that tell a good story. And that's how we ended up with this project. So yeah, no, Vivian, yeah, a lot better. A lot better, yeah.
I feel bad to make you doing everything again, but we want to defend the quality. So make sure everyone leave with awesome project.
Yes, I agree. Thank you.
So I'm sorry for making you do everything again, but hopefully you will be happy with it.
No, you don't need to apologize. I mean, I'm on board. I'm on board and I also want to say my GitHub skills were not it was not doing anything. And Vinod was able to help me with this project, get the GitHub to looking professional. Like the README looks good. I know how to use git ignore. I did not before. So no, it was a good project. A very good learning experience. And Vinod, was very helpful. Like I said, with GitHub and with the visualizations. Yeah, for sure, for sure.
Great. Awesome. Then thank you so much. And yeah, I will wrap it up and hopefully to see everyone's final project coming up soon.